right, guys, give me the next set of notes for the notes 3B.4. Moving on to actually doing two-column proofs and identifying what these SSS, SAS is, everything you saw on the triangle sandwich activity we did before the Thanksgiving break. We're going to go ahead and, with this page right here, the reference sheet's going to go kind of a notes by notes as we're covering each section. The first thing we're going to talk about is included. Whenever you see the words included, we write the words included. What we mean is we're going to mean what's between. Okay, so this saying sides between the angles, so this side right here would be the included side. Okay, non-included, this side is not included because it's not between the two, and we'll go more into detail with that. The notes that we're going to talk about today are going to be your SSS, which is going to be your side, side, side. So your side, side, side. What's going to happen here is all three sides are going to be congruent. Okay? So what this looks like whenever you are going through and doing your two-column proofs, we will see in a moment, is you're going to wind up one side's congruent on each triangle, the second side's going to have 2 tick marks, and then your third side will have 3 tick marks, and you can say that these two are going to be they're going to be congruent by the side, side, side theorem. Okay, so I'm going to go ahead and put this to the side until the next notes. I'm going to bring out the foldable. The foldable here for your side, side, side is we're going to be talking about your 3 different sides here, and to get a third color so that we can see each one, even though they have the tick marks on them. What is happening here is you're going to notice that segment AB right here is congruent to segment DE because of that 1 tick mark. So over here we're saying that if 3 sides of one triangle are congruent to 3 sides of another triangle, then they are congruent. So this is a way we can prove that 2 triangles are congruent. So down here we need to make sure that we're putting congruency statements including our sides. So here we would say if segment AB is congruent to segment DE, that's our first side there. Come over here to our 2 tick marks. We see that segment BC and segment EF are congruent because we have 2 tick marks. So we could conclude that segment BC is congruent to segment EF. And then our third and final side down here, we see those 3 tick marks like we did on the reference page. We say that segment AC is congruent to segment DF. So what's happening here is we're saying that all three corresponding sides are going to be congruent. Therefore, we can conclude that triangle ABC is congruent to triangle going in the same order DEF. Okay? What we're going to do now is we're going to put this to the side, and we're going to take out the little half sheet that says reasons so that we can, because when we open this up, print shot messed up again and did not print how they were supposed to, so we'll have to rotate it, but we're going to need to discuss why we have reasons for sides to be congruent and why we have reasons for angles to be congruent. So some of the reasons for sides to be congruent here are going to be if it's a given. All right, so we're going to highlight the word given. That might be what you write in the reasons column. We have definition of midpoint. Okay, this is going to create 2 congruent segments. You will see all of this. Then you have your reflexive property. A lot of times what happens with this is what I like to call your shared side. And we will see this as well. It's when you have 2 triangles that connect and they share a side together. When we write the congruency statement, it comes out as what we know of as the reflexive property. The reasons that angles might be congruent is, again, it might be a given, so you always look up at the given. We may have vertical angles, and this is something that we need to pay close attention and look for, because if you have vertical angles with 2 triangles, okay, remembering that vertical angles are going to be across the vertex from each other like this. what you will see with triangles is something kind of like this, where you have your vertical angles right here. Okay? And so you could automatically say that these are congruent because they're vertical angles. So this is what it looks like with vertical angles. Without the triangles, here's what it looks like with the triangles. The next three are dealing with your alternate interior, alternate exterior, and your corresponding angles. These are three that we talked about in our parallel lines of transversals, that they are congruent. The thing that's very important to notice with these three right here, though, is they must have parallel lines. So somewhere in a given or on your picture, they're going to have to show you that two lines are parallel, and you can block everything else and you can see that transversal. So make sure that I use the wrong pen for that, but make sure that you highlight where it says parallel lines. The next thing is going to be your definition of an angle bisector. Okay. So we're going to highlight angle bisector here, creating two congruent angles. So we've seen it again, we've seen it like this, where we have an angle bisector creating two congruent angles, but you may also have it something like, here's a triangle, and here's a triangle, and it would tell you that this angle is bisected. Okay, so this is how you may see it with a triangle. All right, so these are just some handy things to have beside as we start going through these 5 different triangle congruency theorems and our proofs. All right, so we'll come back over here and we'll take a look at our proofs. On the first one here, given is that segment PQ is congruent to segment ST, and that is our first statement. So again, reasons for being these sides being congruent is it's a given. So this one right here is going to be a given. I'll change to a black pen to make it easier. See? And then we're going to come over here and make sure that you go ahead and mark everything. These are going to be extremely important. So PQ right here is congruent to ST over here. All right? And then what we want to do is we want to write an S or an A for side or angle. This is a side being marked congruent, so it's going to be very important in the end, so especially when we start moving on to the other 4 proofs, so you can see what order these letters go in. The next statement that they have is that segment QR right here is congruent to segment RT. So we're saying that these are congruent. And we can't really pull anything from up here, so we go up here and say, oh, okay, that was another given right here. So we have another given. The third statement says that R is the midpoint of segment PS. If you look up here, R right here is going to be the midpoint, and this is going to be another given. What we have learned is that whenever you have that midpoint middle of segment PS, it's going to divide it into 2 congruent segments. Now I am putting the 3 tick marks because I've already used 1 and I've already used 2. So here, when we come down to 4, it says segment PR is congruent to segment RS. How did we know that these 2 are congruent? Well, because of this midpoint. And we look up here, that word midpoint right here is telling us this is the definition of midpoint. Going all the way back. Now when we look up here, I forgot to go ahead, but we're going to mark S over here for another side congruent and another side congruent. So now that we see the 3 S's, we know that it was SSS, or side, 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 right here, congruency. So in the end, we can prove that these 2 triangles are congruent based on the side, side, side theorem. So we can just put over here SSS. Okay? The next one here, we're looking at the first given they have is A right here is going to be the midpoint of segment RN. All right, and this is a given. Easy enough. Also knowing that, I know that it's going to split it into 2 congruent segments. So RA will be congruent to AN, and oh look, that's right here. Again, we look up here and we see the word midpoint. The midpoint told us that these were going to be congruent. So this is a definition of midpoint. Next, we come down to number 3. It says segment RG right here is going to be congruent to segment NG over here. We have to put the 2 congruent tick marks. And how do we know this? It's not from up here, but go back up. We're at a dead end. Go back up and look. It's another given for us. Number 4 is going to bring in something that we didn't see in the other one. This says segment AG is congruent to segment AG. We don't even need to look at the picture because we should recognize this is your reflexive property, because what's happening on one side is happening on the other. It's the exact same thing on both sides, just like when you look into a mirror. So this ends up being your reflexive property. And now I want you guys to see what I mean by a shared side. If you go up here, it says segment AG is congruent to segment AG. AG is right here. So we just say it's congruent to itself. This is what I mean by a shared side, because you have a triangle here and you have a triangle here, and they share the side AG, and that's why on the half sheet I wrote shared side. Okay? Next, what we have is we have triangle GRA is congruent to triangle GNA. How do we know this? Well, if you go back up here and we label, we have a side congruent here, we have a side congruent here, and we have a side congruent here. So we come up with our side, side, side. We take one more step though, and now we're saying that angle ARG right here is congruent to angle ANG. So we have to figure out how on earth did we know that those are congruent? Well, look up here. We've already established that the 2 triangles are congruent. So based on our CPCTC notes, we took corresponding parts of congruent triangles are congruent. We already know that these 2 triangles are congruent. So our reason for this now comes down to our CPCTC. All of the corresponding parts are going to be congruent because we've already proven the triangles are congruent. So after that, we can say any other corresponding parts will be congruent. So that's where CPCTC comes into play. After we have already proven triangles are congruent, it lists something else. Some other corresponding parts are congruent. We could say, well, how do we know? Our CPCTC. That's what told us. Once we've established that they are congruent, every single corresponding part is going to be congruent. And we'll see more of that with the other proofs as well. The last one here is going to be segment AC over here. Segment AC is congruent to segment AD, as we see here. This is a given. And we could go over here and say, okay, segment AC and segment AD, we have a side that's congruent. This will come really helpful whenever we're doing mixed proofs. We're also told that segment CB right here is congruent to segment BD right here. So we can mark those congruent. And how did we know that? It was another given. And we have another side. Statement number 3 says segment AB is congruent to segment AB. There's that mirror image. Same thing on both sides. Reflection. So your reflexive property. We go up here and we see AB. It's one of those shared sides. So we have another side. So we can conclude that these 2 triangles are congruent based on, well, we'll look up here, we have S, S, and S. Side, side, side. And these are a lot of the examples you'll have on, your side, 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 and proving sides are congruent for these. And then the next proofs we will work on the next video.